In today's video, we will be continuing the discussion on linear equations. In particular, we will be solving systems of linear equations. A system of equations includes multiple equations with common variables. This means that these equations can be sketched on the same pair of axes. And solving the system of equations means that we are looking for the point or points where the two lines intersect. For a system of linear equations, there exist three cases. If we get one solution, then the system is considered consistent. This means that the lines intersect at one point. If we get zero solutions, then the system is inconsistent. This happens when two lines are parallel. The third case is if we get infinite solutions, which means that the two lines overlap. We will look into all three cases in examples later in this video. So, let's first learn about three common methods to solve our system of linear equations: elimination, substitution, and the graphical method. Two other notable methods exist, the matrix method and Gaussian elimination method, but they will be covered in a different video. First, let's go over elimination method. As the name suggests, we aim to eliminate or get rid of one of the variables. This way we can solve for the other one. The steps to do this are as follows. Multiply one or both equations with a constant to make the coefficients of one variable equal. Add or subtract the equations to eliminate one variable. Solve for the remaining variable. Substitute the value back to find the other variable. This method is advantageous to use when the coefficients can easily be made opposites. Let's try an example. X plus 3y equals 18 and negative 3 x plus 5y equals 2. An easy way to approach this is finding the LCM of the coefficients of x or the coefficients of y. This helps us find a common multiple for the coefficients. Let's try taking the coefficients of the x term, which are 1 and 3. We can ignore the negative sign for this part. The LCM can easily be found to be 3. Therefore, to make these both equal to one another, we can multiply the first equation by 3. So it becomes 3x plus 9y equals to 54, and let's call this equation number 3. Now, we can write the second equation underneath it and add or subtract the equations. Since, in the first equation, 3x is positive, and in the second equation it is negative. Then to get rid of this term, we can add both equations. This results in 3x minus 3x, which gives us 0. 9y plus 5y equals 14y. 54 plus 2 equals 56. Hence, we have 14y equals 56. We divide both sides by 14, which yields the answer y equal to 56 over 14, which is 4. Now, to find x, we plug in this value of y into any of the three equations we had. Let's just plug this into equation number 1, and we get x plus 3 times 4 equals 18, or x plus 12 equals 18. We can take the 12 to the other side, where it will now subtract, and we get the answer x equals 6. Therefore, the solution to this equation is x equals 6 and y equals 4. Or 6, 4 is the point of intersection. We just have one solution, which tells us the system is consistent. To confirm our answer, let's try the same question by sketching them or using the graphical method. In the previous video, we learnt that it is easiest to sketch a linear equation by representing it in the slope-intercept form first. Let's take x plus 3y equals 18. We take x to the other side, and then divide both sides by 3. This results in y equals to negative 1x over 3 plus 6. Hence, the slope equals to negative 1 over 3, and the y-intercept is 6. We begin by plotting the y-intercept on the graph. A slope of negative 1 over 3 means that the change in y value is negative 1 when the change in x value is 3. So we move 3 points to the right and 1 point downward. That gives our second point. Connecting these 2 points gives us our line. The second equation we have is negative 3x plus 5y equals 2. Let's find the points for this using a different method. Let's just choose two values of x and plug them in one by one to find the corresponding y values. We first plug in x equals 0. This gives us 5y equals 2 as the first term goes to 0. Then we divide both sides by 5, which gives us y equals 2 over 5, which is 0.4 in decimal. Our first coordinate is 0, 0.4. Now let's try x equals 1. This results in negative 3 plus 5y equals 2. The 3 adds to the other side and becomes positive. The equation becomes 5y equals 5, dividing both sides by 5 yields to 1, producing the coordinate 1, 1. Now we just connect these points and extend the line, so we get a point of intersection, and our answer is verified as x is 6 and y is 4. The third method is substitution. For this method, we take one of the equations and make one of the variables the subject. Then we substitute this expression into the other equation. We solve for the variable and substitute this value back to find the other variable. This method is useful when one equation is already solved for a variable. For example, let's try the question. 2x plus 3y equals 8 and x minus y equals 4. Now, we can see that the second equation is easier to manipulate and make one of the variables the subject. So, let's work with that and try to isolate x. To do this, we simply take y to the other side, where it adds now, and we get x equals y plus 4. Now, step 2 is to substitute this into the other equation, which then gives 2 bracket y plus 4 plus 3y equals 8. Expanding the bracket gives 2y plus 8 plus 3y equals 8. We take the 8 on the left side to the right, which results in 5y equals 0. Therefore, y equals 0. Now, we plug this back into x equals y plus 4, which gives us x equals 4. Let's try a different method to verify the answer. We plug these values back into the two original equations, and if both sides equal one another, then our answer is correct. Plugging 4 and 0 into the first equation gives us 8 equals 8, and into the second equation gives us 4 equals 4. Hence, our answer is verified. And since we have one solution, that means that our system is consistent.
That's plenty from us. Time for you to work on a question. Feel free to choose any method.
Time to move on to two more short examples. Consider the system 2x plus 3y equals 7 and 4x plus 6y equal 12. Now, it is easy to identify that elimination will be a better method. We can simply multiply the first equation by 2, which results in 4x plus 6y equals 14. Now, since our coefficients have the same sign, we will subtract the equations. 4x minus 4x gives 0. 6y minus 6y gives 0. 14 minus 12 gives 2. This is interesting now that we get 0 equals 2, but we know that 0 cannot equal 2. This means the system is inconsistent, and the lines are parallel to each other. Another system is given by 3x minus 2y equals 6 and 6x minus 4y equals 12. This question is also easily solvable using elimination. If we multiply the first equation by 2, it becomes 6x minus 4y equals 12. Then we simply subtract the equations. Oh, wait! The two equations are the same, which means the two lines overlap, or there are infinite many solutions. This results in the scenario 0 equals 0, and this is the characteristic of a dependent system.